2 is less than 5, so we generated that row and we feed it back in. And we select 2 plus 1 from data, where 2 is less than 5, and so on. And eventually we end up generating 5 rows. Then we can select R, sysdate plus R from data, and we just sort of generated some data here. This is useful for outer joining, for example, when you need to fill in a week's worth of information, but your database might only have observations for Monday, Wednesday, and Friday. This lets you fill in and make up Tuesday and Thursday, for example. Another use of this that you might not think of off the top of your head is you no longer need to solve Sudoku puzzles. You can just write a SQL query in order to do it for you now. So hopefully this page will come up. Okay, so somebody took this and said, if you have a Sudoku puzzle that looks like this, what I would like you to do is take all the numbers and put them into a string and just leave blanks where there's missing numbers and then feed it into this query. Okay? And this query will, if you run it, this is their SQL Plus output, give you this big string of numbers down here at the bottom. And that string of numbers, I've filled in all the blanks. I've solved your Sudoku puzzle. Okay? So no longer do you have to do it by hand. All you need is a database and Dual. Right? Now, I don't anticipate you're going to use it to solve Sudoku puzzles. However, you can see there's some interesting things you might be able to do with this now. You can solve problems in SQL that were not really solvable before because you have recursion for the first time. Number 5, improved time travel. The database for a long time, going back to version 4, has had this feature called multi-versioning and read consistency. When you open up a query, we froze the result set of that query at that point in time. If, as you were fetching through the result set, you would encounter data that had been modified after your query began, we would use undo information to put the data back the way it was when your query started. We would roll back the information. In 9i, we exposed this to you and called it flashback query. The developer could select star from a table as of 3 hours ago. And what we would do is roll back the table changes to 3 hours ago as we encountered blocks that had been modified. The theoretical limit for flashback query was 5 days, and it was based on undo. If you tried to flashback more than 5 days, it would never work. And in fact, if you even tried to flashback 2 days, it probably would not work because it relied on the undo information still being on disk. And most DBAs that I know won't keep 2 days of undo on disk. They have a hard time keeping 3 hours of undo on disk because you can generate a lot of this stuff over time. So the flashback query was definitely bounded by a fixed window of time, usually measured in a couple of hours, maybe a day or two. In 11G, Release 1, they introduced a flashback data archive. And the goal here was to give a long-term flashback query capability for individual tables. So this is done table by table by table. And a guy I know, Jonathan Genick, wrote a really good Oracle Magazine article on this when it first came out. Sort of describes it if you want more information. But in a nutshell, the way that it works is your application performs its normal inserts, updates, and deletes. This, of course, modifies data in the buffer cache, but at the same time generates undo data, undo information, rollback. When you commit, a new background process, FBDA, Flashback Data Archiver, will come and read the undo information and find undo for tables that the DBA has said we need to be able to query for years. And when it finds that undo, it would apply it to the original database block, roll back the change, get the row as it looked before your update, and insert that copy of that row into a flashback data archive. This gives you the ability now to query months and years in the past. We don't have to roll back a month's worth of changes now to flashback a month. We just go to the record that was in place a month ago. We have it already. We don't need to apply the undo over and over again. When we first introduced this, the flashback query part of it worked really well, but it imposed a couple of limitations on the DBA. They could not drop a column. They could not truncate a table. They could not reorganize the table. In fact, they could not do anything to the table that did not generate undue information for the change. We weren't able to track it in the archive. So it was an interesting feature, but not everybody could use it right away because of that one limitation. No more reorganizations. Can't drop a column. DBAs can't do the things they were used to being able to do. In 11G Release 2, they've added support for pretty much all DBA-related operations. I can drop a column in the production table, and it will drop the column in the production table, but it will keep it in the flashback data archive. Because if you go to query the data as of 2 years ago, and that column existed 2 years ago, we need to be able to produce it. So we have the ability for the table to get slightly out of sync with the flashback data archive as far as the set of columns go. Other things you can do. You can do your reorganizations. You can do your truncates. We can capture that information. Additionally, if you want to, you can take the table out of flashback data archive mode temporarily. You can disassociate it from the history so that you could then partition that table or create it as an index organized table, do some massive reorganization to it, okay, and then reassociate it with its history. So the DBA can basically unplug it from the archive, do whatever they need to it, and then plug it back in. So pretty much every DDL operation they need to do is now supported. Number 6, you've got mail. And this has nothing to do with the AOL internet provider service out there. This has everything to do, though, with when a file arrives in a file system on my database server, I would like something to happen to it. In the past, if you had a need to do something like this, you wrote the program outside the database and scheduled it with some operating system utility, creating another sort of new thing, a credential in the database. When I'm processing these files, I'd rather not work as the Oracle operating system account. That has too many privileges. It can read too many things. It can write too many things. I can make too many mistakes. When this process runs against the operating system, I want it to run as me with my privileges. So what I'm doing is storing in the database my username, my password in an encrypted format so that the database can become me in the operating system and perform this operation. I'm creating a directory. This is where the files that I want to process are going to be in the operating system, home Kyte files. And what I want to do is, as files arrive, I want them to automatically be loaded into this table. So I don't want to have to go and run a program to load them. It should just happen. And in order to do that, I needed to write a little bit of code, a stored procedure. And this stored procedure takes one input, and this is a new data type, a file watcher result. And all this is metadata about the new file that just arrived. It's things like the directory path, the timestamp on the file, the actual file name. So I save this data into the table, load an empty clob, and then load the file from the operating system into the database. Set this up with DBMS Scheduler so that there's a job out there running now, checking this file. I create a file watcher. This is the actual thing that will run. And this file watcher is an internally defined object. I give it a name. I tell it what directory to watch. I tell it what kind of files to look for. I don't have to look for every file. I might just look for star.txt, for example. But here I was interested in any file that would appear. I want this to run with my credentials, so that's the thing I created. And all I do is I enable that job, and a couple of seconds after doing that and putting a file into the directory, I can query my table, and the data is there. And as new files arrive in this directory, they're automatically processed.